Hello, my name is Rod Hadrian. I'm at the University of California, Irvine, the engineering department. We're currently testing lintels and beams on a 3D panel or Tridipanel, or commonly called the Tridipanel building system. Here you see one of the panels, or one of the lintels, has been cut in a 16-inch piece. It's actually upside down right now. That piece at the top will go into the wooden form at the bottom. You can see where the foam has been removed from the top and a piece of wire mesh placed on the top. This is called U-mesh. I'm going to bring the camera around and show you to where you can see down the panel. This will be a small concrete beam. Basically, that's the panel right there. It's prefabricated. Any length up to 40 feet long. Different thicknesses. The panels start at 8 foot in length. Go up to 40 feet in length. Two-story houses, we use these types of panels standing upright over rebar. You can get some idea of the thickness here as I get a close-up. You can see the cross wires where they're welded through the panel. These panels are going to be tested for ceilings, roofs, and floors. There's the crosswire. Comes all the way through the panel. You can see it right there. It comes through one side and sticks out the other diagonally. Hey Freddie, hold the saw up. I want to show the viewers the saw blade if you can. Just turn it sideways for me if you can. That gives you some idea of what the blade looks like. We can get it to stop. This saw works pretty well. There are many methods of cutting, but this one is one that we like. You can see the diamond edge blade and so on. It's not too heavy. Thanks, Freddie. Here are a couple of the pieces that have already been cut that we're going to be preparing with the rebars here as soon as Julio gets the foam removed. We're at the University of California, Irvine. We're preparing cement mortar, a Portland cement mortar. 3 parts sand, 1 part Portland cement, 20% lime. The ratio 20% lime to 1 part cement. Approximately 4.5 gallons of water per mix. You can see Bill Hadrian down there playing with a mix. It's actually a tight, what we call a tight mix. Here you can see the mortar mix that Billy just put on the mudboard for Kai. And Kai's applying it right now onto this 32-inch wide lintel. This gives you some idea of the cement application. On a lot of the smaller jobs, we can actually hand apply the cement. On the larger jobs, then we bring in a pump. By taking the tray apart, we lift that piece off and separate it, and the cubes come out, and then we can take this cube back to the laboratory or send it out to a laboratory, and they'll put pressure on this, and then they'll use a multiplier. On this particular cube they divide by 4, and because it's 4 inches of surface area, it's 2 inches by 2 inches, and then we'll divide that amount of pressure by 4, and it gives us the PSIs. We're in the lab at the University of California, Irvine, testing Portland mortar. This cube is having pressure applied to it right now. You can read the numbers. can see the size of the hydraulic ram that's applying pressure. We currently have 18,000 pounds being applied, going quickly. The previous panel that we had here 15 minutes ago actually broke at about 27,000 pounds. Down at the bottom, you can see the gauge there, and that gauge at the bottom is fastened there at the top of the panel. You can see the little clip there. That's measuring deflection. Where are we at right now with the deflection? About 5/8 of an inch. And the pounds? How many pounds? 21,000 pounds. All of the cement that was placed on this beam was Portland cement mortar. We're at 23,000 right now. 23,000 pounds. There she went. Here you can see the two little blue markers there that are applying the loads equally. There's our panel right there. You can see it. It's 24 inches wide, 8 feet long. I'm going to take you over to the computer for a moment. And on the computer you can see the loads, they're changing. You can see the force being applied. It's almost 23,000 pounds. It's going quickly. There, now we have 23,000. There you can see the graph. Everything's good to go. Now we're 27,000 pounds load on this 24-inch wide lintel with no rebar in it. We have a piece of metal mesh wrapped around the bottom called a U-mesh. It's a 2-inch by 2-inch 11-gauge wire. Normally we would stand these panels up on end. This particular test is just to show the strength for the headers and beams. Most of the home builders would be using a steel I-beam, and we like to do it with a concrete, so that's why we're trying to get this information. 33,000 pounds right now. 34,000 pounds. 35,000 pounds. What's the deflection on it now? 36. I think that was the end right there.
6,000.
You can see the graph, everything looks good. It's just climbing straight up. This is the product that we distribute and sell and build with all across America. This test is being performed for our new ER report. It's ER 5618. I'm at the University of California, Irvine, Seth Hall in the testing laboratory. There you can see we've currently got almost 38,000. We use this system for tornado-proof homes, hurricane-resistant homes, earthquake-resistant homes, totally fireproof. We get a 4-hour rating. Oh man, you got it right there. We have 20,000 kips right now, 21,000. They're going up about 4,000 pounds per minute. Right now we're at 28,000 pounds. We're 4 minutes into the test. These guys are worried about me being too close. We're at 30,000 pounds right now, or 24,000 pounds or 34 kips. 36,000.
50 kips.
We're at 50,000 pounds right now.
54 kips, Rod.
54,000 pounds right now.
57 kips.
57.
58.
58.
59.
59. Doggone thing, it failed at the top.